design coursework. The scheme I chose was 5 new self-gated apartments in Brixham, South Devon. The architects were Kay Elliott, the engineers were Kay Consultants, and the design was done on the 25th of November 2019. I decided to choose this project as I was one of the design engineers, meaning I had insight that I wouldn't have been able to have on a different project. It is also a good example of where reinforced concrete has been used effectively. Reinforced concrete was used as large flat slabs supported by columns were needed. Regular concrete is relatively brittle, however the steel reinforcements resist tensile force. It also is extremely durable and requires little maintenance, making it perfect for the project, as well as nearly 100% of the rebar being recycled. Here is my sketch of the project from the front, including annotations of key design aspects. Here is the loading used for the design. The wind loading was calculated using a MetSpec software that takes into account the surrounding area. These are my load path diagrams with both vertical and lateral forces. This is a Tekla 3D model produced that shows the loading on the structure. Here are the loading values used for the slab design. My results are a comparison with the results used for the actual design that was calculated using Tekla. This is the categorized loading on each slab. The final design was H12s at 150 centres throughout, as well as H16 at 150 centres at the top of the columns, as shown in this diagram. This is my column design. From the chart, the loads are nominal, therefore minimum steel was required. The final design was 300mm diameter columns with 6 number H16 main bars with 8mm links at 300 centres. The most effective way to reduce embodied carbon in this design would be to reduce the slab thickness and reinforcement. I have proposed reducing the number of hot tubs to reduce load on the slab from 7.5 to 2.5, and to line up the first floor with the supporting columns to allow for a smaller slab design. Thanks very much for listening.